Light-emitting diode, LED, status indicators. Have you ever looked at the front of a computer or a large server rack and noticed those tiny blinking lights right next to the hard drives? Those are the light-emitting diode status indicators. In the simplest terms, they are the check engine lights for your digital storage. When you are studying for your CompTIA A+ Core 1 certification, specifically the objective to troubleshoot drive and redundant array of independent disks issues, you absolutely cannot ignore these visual cues. They are your very first clue that something is going wrong before the entire system crashes and takes all the data with it. To get your perfect score of 900, you have to know how to read this visual language fluently. Mastering this visual diagnostic skill will not only guarantee you a perfect score on the A+ exam, but it will serve as a massive advantage when you begin your computer information systems classes even further down the road. As you transfer to the University for Digital Forensics, recognizing a failing drive immediately will be a critical part of preserving digital evidence on a compromised enterprise server. Let us take a deep technical dive into what these lights are actually telling us. On a standard, single hard drive or solid-state drive inside a basic desktop computer, the light-emitting diode usually only has one color and one job, which is to show drive activity. If it is blinking rapidly, the drive is actively reading or writing data. If it is solid or completely off, the drive is idle. However, when you step into the corporate world and deal with a redundant array of independent disks, or RAID, the game completely changes. In a server or a network-attached storage device, the drives are installed into special slots called a backplane, which connects them directly to a dedicated RAID controller card. This controller manages multiple storage drives at once and uses a complex system of multicolored lights to communicate the exact health and status of every single physical drive in the array. For your exam, you must memorize the universal color codes and blinking patterns used by enterprise storage systems. A solid green light almost always means the drive is completely online, healthy, and ready to be used. A blinking green light simply means the drive is healthy and actively processing data. The critical troubleshooting begins when the colors change to amber, orange, or red. An amber or orange light is the universal warning signal in the information technology industry. If you see a solid amber light, it generally indicates a predicted failure. This means the drive is still technically working and serving data, but its internal self-monitoring analysis and reporting technology has detected an excessive number of physical read and write errors. The drive is actively warning the hardware controller that the mechanical parts or flash memory cells are about to die very soon. This is your professional cue to order a replacement drive immediately before a catastrophic failure occurs. If the light turns solid red, or on some proprietary systems, a very fast blinking amber, the drive has completely failed and has been forcefully taken offline by the storage controller to protect the rest of the array. This is exactly where your knowledge of specific RAID levels becomes incredibly important. If the array is configured as RAID 0, which provides absolute zero redundancy, a red light means total data loss, and the entire array has failed instantly. However, if the array is configured as RAID 1, 5, 6, or 10, the array will continue to function in what is called a degraded state. In this degraded scenario, the correct professional troubleshooting step is to physically pull the failed drive out of the hot-swappable server bay and insert a brand new, completely empty drive of the exact same storage capacity or larger. Once you securely insert the new drive into the bay, you must watch the light-emitting diode status indicators very closely. You should see a specific alternating pattern, often blinking green and amber simultaneously, or a slow, rhythmic green pulse. This specific blinking pattern tells you that the RAID controller has successfully recognized the new empty drive and has actively started the rebuilding process. During a parity rebuild, the controller uses complex mathematics from the surviving drives to completely recreate the missing data and write it onto the brand new drive. This heavy process can take hours or even days, depending on the total size of the array and the speed of the disks. The absolute most catastrophic mistake a technician can make, and a classic trick question you will see on the certification exam, is to pull out a drive while it is showing this specific rebuilding light pattern. If you remove a rebuilding drive, or accidentally pull a second healthy drive during this incredibly fragile process in a RAID 5 array, you will instantly and permanently destroy the entire array and all of the corporate data residing on it. By understanding that these tiny lights are directly tied to the hardware health, the controller's logic, and the delicate parity rebuild process, you will easily conquer the storage troubleshooting objectives on your test.